Have you ever admired the shape of the clouds? Clouds form when water vapor in the atmosphere rises and meets cool air. The cool air causes the water to then condense into droplets. The same process of condensation is at work during distillation, which is essentially when a liquid is purified through temperature changes. Good day everyone, we are the Group 8 and we are going to present distillation. The topic outline of this presentation is first, the definition of distillation, distillation process, distillation column, types of column distillation, components of distillation column, and lastly, basic operation and terminology. So, what is distillation? Distillation is a widely used method for separating mixtures based on differences in the condition required to change the phase of components of the mixture. To separate a mixture of liquids, the liquid can be heated to force components, which have different boiling points into the gas phase. The gas is then condensed back into liquid form and collected. Repeating the process on collected liquid to improve the purity of the product is called double distillation. Although the term is most commonly applied to liquids, the reverse process can be used to separate gases by liquefying the components using changes in temperature and/or pressure. So, the condensation which I mentioned at the beginning of this presentation regarding about the clouds, that results when a warm vapor cools is a key process in distillation. You might have also heard of distillation as method to produce alcoholic spirits. In chemistry, it can really be any liquid as the definition earlier suggested. Distillation process. The process of distillation begins with heating a liquid to boiling point. The liquid evaporates, forming a vapor. The vapor is then cooled, usually by passing it through the pipes or tube at lower temperature. The cooled vapor then condenses, forming a distillate. The distillate is a purified form of the original liquid. When the liquid evaporates, many impurities are left behind, so they are not present in the distillate. Shown in your screen are the example of distillation process. The first photo is an example of simple distillation. The second one is batch distillation. The third one is a design of a column distillation. So chemists and chemical engineers use distillation to purify compounds in solution or to separate mixtures of solutes. For example, different compounds have different boiling points. So this property means that a more volatile compound will evaporate at lower temperature than a less volatile compound. So let's look at this way. Imagine you have a mixture of two compounds. If these compounds have different boiling points, you can separate them using distillation. The process takes advantage of substances readily changing their states of matter from a liquid phase to a gas phase and back to a liquid phase again. The key step is to raise the temperature of the mixture to a point above that of the compound with the lower boiling point. But you also have to make sure it's below that of the compound with the higher boiling point. The compound with a lower boiling point will then evaporate, leaving beyond the compound with a higher boiling point. If the vapor is then condensed, you're only going to have the compound with a lower boiling point since you separated the two compounds. Simple, right? So, next is the distillation column. The distillation column is made up of a series of stacked plates. See, shown in the photo, a liquid feed containing the mixture of two or more liquids enters the column at one or more points. The liquid flows over the plates and the vapor bubbles up through the liquid via holes in the plates. As liquid travels down the column, the vapor times due to multiple plates a critical process in distillation columns. So the liquid and vapor phases are brought into contact because as one molecule of higher boiling material converts from vapor to liquid phase by energy release, another molecule of the low boiling material utilizes the free energy to convert from liquid to vapor phase. So in a distillation column, we have distillation tray. So a tray is essentially acts as mini column, each accomplishing a fraction of the separation task. From this, we can deduce that the more trays there are, the better the degree of separation, and that overall separation efficiency will depend significantly on the design of the tray. So trays are designed to maximize vapor-liquid contact by considering the liquid distribution and vapor distribution the tray. So this is better because vapor-liquid contact means better separation at each tray, translating to better column performance, of course. So less trays will be required to achieve the same degree of separation. Attendant benefits include less energy usage and lower construction cost. So there are three types of trays. We have safe trays, we have bubble cap, and valve tray. So the first one is safe trays are simply metal plates with holes in them. So vapor phases straight upward through the liquid in the plate. The arrangement, number, and size of the holes are design parameters. Next one, the bubble cap tray. So this tray has riser or chimney fitted over each hole and a cap that covers the riser. The cap is mounted so that there is a space between riser and a cap to allow the passage of the vapor. So vapor rises through the chimney and is directed downward by the cap, finally discharging through slots in the cap and finally bubbling through the liquid on the tray. So the last one, the valve tray. So in valve tray, perforations are covered by liftable caps. Vapor flows lifts the caps, thus self-creating a flow area for the passage of the vapor. The lifting caps directs the vapor to flow horizontally into the liquid, thus providing better mixing than is possible in safe trays. So in a distillation column, in order to increase the vapor flow rate, we have called the flow regimes. So first one, we have the bubble regime. So in bubble regime, our vapor flow rate is low. Liquid phase is close to being stagnant with only small bubbles rising through it. Then lastly, low contact between the vapor and liquid phase, which means that low stage efficiency. So low contact is equal to low stage efficiency. The next one is the foam regime. So in foam regime, vapor flow rate is higher compared to bubble regime. So vapor phase is rapidly rising through the liquid phase. Good mixing between the vapor and liquid phase equal to relative high stage efficiency. If the foam is too stable or there is too much foam, flooding may occur. So flooding is when foam filling the space between each tray. The third one is the froth regime. So vapor flow rate is even higher compared to foam and bubble regime. So the surface of the liquid phase boils violently and some splashing may be observed. So excellent mixing between the vapor and liquid phase equivalent to high column efficiency. So most commercial distillation columns are operated in froth regime. The fourth one is the spray regime. So vapor is very well mixed in this regime. So poor liquid mixing will equal to low mass transfer rate, which means low stage efficiency. So small increases in vapor velocity can cause the column to go from the froth to the spray regime and cause a significant decrease in stage efficiency from, for example, SOFA, from 65% stage efficiency to 40 stage efficiency. So the next slide will be explained and presented by my partner, Ms. Cacciatore Sanchez.
Hi everyone, I'm Cacciatore Sanchez and I will be discussing the second half of our topic for today, which is distillation. So I will be discussing types of column distillation, components of distillation column, and the basic operation and terminologies. So let's start. So the first one is the types of distillation columns. There are two main categories of distillation column, which are known as the batch distillation column and the continuous distillation column. So for batch, the main idea of this is that the feed is introduced batch-wise. So batch distillation is very flexible but is only used for small and medium-sized capacities. The feed to the column is introduced batch by batch. So the first set of batch undergoes the whole distillation process, and then after, another set or another batch of feed undergoes the whole distillation process, and it just repeats until the main objective is achieved. So batch distillations are frequently used in the pharmaceutical industry for small-scale solvent recovery applications and in wastewater treatment units of small capacities. So there are two possible operational modes for batch process. The first one is that the batch distillation has a fixed reflux ratio. So what happens here is that the compounds are separated according to a defined product-specific time schedule. This is based on the components' boiling ranges, beginning with light boilers and ending with the heaviest. And then the second operational mode is the batch distillation has a varying reflux ratio. So this allows the distillation at constant distillate concentration. It is applied where a distillate with constant physical behavior needs to be obtained. So this one is an example of a batch distillation column in chemical plants. So the second category of distillation column is known as the continuous distillation column. So what happens here, or the main idea of this, is that the feed is introduced continuously. So continuous distillation is more economical and energy efficient for larger units since it is capable of handling high throughputs. The feed to the column is introduced continuously, meaning that there will be no interruption unless there is a problem to the whole distillation process or the whole distillation column. Continuous distillation are frequently used in the petroleum refining, natural gas processing, and petrochemical production. Also, continuous distillation is more used in the industry than the batch distillation. So furthermore, first is this one. This is a picture of or an example of a continuous distillation column in the industry. So furthermore, there are different types of continuous distillation column. So they are classified individually. So the first two can be classified according to the nature of the feed that they are processing. So for binary column, the feed contains two components only, while for the multi-component column, feed contains more than two components. And then for multi-product column, it depends on the number of product streams that they have. So in this one, columns contain more than two product streams. And then for the fourth and the fifth type of continuous distillation column, they are classified according to where the extra feed exits when it is used to help with the separation. So for the extractive Distillation. This is where the extra feed appears in the bottom product stream, while from the azeotropic distillation, the extra feed appears at the top product stream. And then there are also different types of column internals for the continuous distillation column. So the first one is the tray column. This is the type of an internal where trays of various designs are used to hold up the liquid to provide better separation between vapor and liquid. While for pack column, this is a type of continuous column interval where packings are used to enhance the separation between vapor and liquid. And that is the two types of distillation column. So next up is the main components of distillation columns. So the main components of distillation columns that is used to separate mixtures is first the vertical shell. So this is where the separation of the liquid components is carried out. And next is the column internals, which are the trays or plates and or the packings. So these are used to further separate components. Then we have the reboiler. This is where the vaporization is conducted in the distillation process. And then the condenser, where cooling and condensation of the vapor leaving the top of the column. And the last one is the reflux drum, which stores the condensed vapor from the top of the column so that the reflux can be recycled back to the column. So let me just show you a whole distillation process. This one. So this one right here is the vertical shell. The vertical shell holds the column internals, which may be the plate or trays or the packing. So this one is those column internals. And then we have the reboiler in here on the bottom side, which vaporizes the components. And then at the top we have the condenser here, which cools and condenses the vapor leaving on the top here. And then here is the reflux drum. So this one is used to hold the condensed components, so it can be recycled back to this stream and have another distillation process. But also it also holds the other side, which is the overhead product. So anyway, this will be all discussed shortly. So next is the basic operation and terminology. So first things first is the feed. So feed is the liquid mixture that is to be processed and introduced near the middle of the column, known as the feed tray. So like I have here, so the feed goes in through the vertical shell. And then the feed tray splits the column into two. The top, called the enriching section, and the bottom, called the stripping section. In the stripping section, the feed flows down the column where it is collected at the bottom in the reboiler. In the reboiler, heat is supplied to produce vapor. Typically in chemical plants, steam is the source of heat, while the output streams of the other columns are the source of heat for refineries. So it depends on where the distillation column is used. And then, after the reboiler, the vapor raised in the reboiler is reintroduced into the unit at the bottom of the column. Bottom products, which may also called as bottoms by others, is the liquid removed from the boiler. So let's just focus first here. This is the feed. It is introduced to the vertical shell or to the column, and this are the tray. The tray that process the bottom side or the stripping section goes through a reboiler. In reboiler, there are like two products in there. One that goes back to the column to be processed again, and the one which is called the bottom or the bottom product. And then next, in the enriching section or in the top section, as the vapor moves up the column and exits the top, a condenser is used to cool it. The condensed liquid is stored in a vessel known as the reflux drum. So here in the enriching section or in the top section, the vapor moves up the column, it exits, and then it goes through a condenser. After being cooled and being condensed by a condenser, it goes through our reflux drum. And then there can be also two products in the reflux drum. So the liquid that is recycled back into the top of the column is called the reflux, while the liquid that is removed from the system is called the distillate. So here in the reflux drum, the one that goes back to the column to be reprocessed or to be distilled again is called the reflux, while the product is just called distillate. And that ends the presentation for today. Thank you for listening. Bye.